Here we're installing a virtual machine that will run Ubuntu and ROS. First I'll launch my VMware Fusion because I'm on a Mac. If you're on a Windows machine, it'll be a VMware workstation. I'll call the virtual machine ROS VM. Then we'll change the settings a bit to have more processor cores and a bit more RAM, so I'll use half of the RAM in my computer, 8 gigs. Then we don't need to enable any of the advanced options. Go back to the settings, so we'll use the 3D acceleration. Now we'll connect a CD, so we'll connect the ISO image of Ubuntu so that you can download from the Ubuntu website, which will be used to install Ubuntu. Remember to connect the CD. Then we'll choose the CD as the system startup disk. Yes, perfect. And we'll start the machine. So the machine will boot, and we'll just click install Ubuntu. You can try Ubuntu from the CD if you want to see if it works on your machine. I'm going to check off download updates and install third-party software while we're installing. So this will take a short while. Then it'll ask if I want to erase the disk and install Ubuntu. I want to do that because this is a virtual machine, and I'll just erase everything. There's nothing on there. It's a new machine. So if you're not happy, you can go back and change things, or you can continue. We're not going to encrypt anything because we're not concerned with security here. Also, I'm in Aalborg, which is not too far from Copenhagen, but for the heck of it, let's go to Aalborg. My keyboard setup is Danish, and here you can set up whichever keyboard layout you have, and you can test that your special keys work. Mine do. So I'll continue. I'll put in the name ROS user, and the username will be ROS, and the password will be ROS. I'll log in automatically. I'm not concerned with any security or anything here because my virtual machine is secured by my actual login credentials on my machine. So I'm just fast forwarding through the copying phase. So all the files have been copied, and we'll restart the virtual machine. Unfortunately, sometimes the virtual machine will hang at this point. So I'll just shut down the computer and restart it manually. And now it actually boots into the installation that we have done. So now we've actually installed Ubuntu. So let's set the resolution to something that allows for a bit more screen. We'll use the Ubuntu launcher, and under display we'll choose something that fits into this screen size. This looks good. And there's an apply button right there. Perfect. Does it look good? It does. Oh, we're just missing a bit of pixels in the bottom of the screen, so we'll just notch it a bit down. There, 14:9 key. There we are. Alright, so we have our window, and I'll close it down. So we need to install the OpenVMtools that allows for the graphics driver to run smoothly in a virtual machine. We'll do this through the terminal. The terminal is really useful when you're developing and when you're actually getting your hands dirty in a Linux or any machine for that matter. I'm going to search for the OpenVMtools through the package system on Ubuntu and Debian. That's called apps. I've got an error here. That's because it's apt-cache that I need to search, not apt-get. So we'll change that, apt-cache. Search for the OpenTools. So we see that there's 4 packages: the OpenTools, the OpenTools Dev, the OpenTools Desktop, and the KMS. So actually, I'll just install. I've checked this out. That I just need to install the OpenVMtools package with everything that it suggests to install alongside it. First, I'll just update the cache, so we'll get the newest version. And we'll say install everything that is suggested from the package OpenVMtools. There we are. Oh, sorry, we need to also say, so install suggest is an option to the install verb. So install that. Yes, continue. Why? And we'll just fast forward through this installation. There we are. So it's complete, but it built specifically for the Linux image 4.8, and I'll just restart because it built a kernel module. So just to make sure everything is installed, I'll just reboot. But let's just have a look here. If everything is installed as it should be. I'll use app. This is like the pre-printing version of app. So we'll say what is upgradable, and there's actually a lot, even though we ask the system to download the updates. So there's a lot of stuff that can be upgraded. You see all the green stuff is the packages that needs to be upgraded, and we also have the Linux kernel, the image here, and it's actually 4.10. So let's install all these updates to get the newest Linux image and all the other outdated packages. Alright, I'll just fast forward through this. On your computer it'll take a little more time if you choose to install all this. Alright, so here we'll check for the Linux version of the kernel. It's 4.8, and we just installed 4.10, but that won't take effect until you actually restart the kernel. The kernel is the very core of the operating system. Alright, so reboot. Let's try once more. You'll notice that from now on I'll not open the terminal through the launcher, but I'll just use this hotkey Control-Alt-T, which opens the terminal. So now we have the Linux version 4.10, perfect. And we'll reinstall these OpenVMtools because I noticed that it said that it built specifically for the Linux kernel that was installed. Oh, apt-get, there we are. And so as you can see, it is oh, we need also the other two packages to reinstall those. Well, let me be honest, I don't really know if it's necessary to reinstall. I'll just do it for good measure, just to be sure. You can see the screen changed size, so something on the system side changed. So after reinstalling these OpenVMtools, I'll just reboot to make sure everything is in the right place. So now we got the big screen as well. Perfect. So now we've actually got Ubuntu installed and we've got the VM tools installed, so it will run smoothly on our virtual machine. Next up, we'll install some ROS. And if you want to do this, go to ros.org. This is the website of ROS, and there's all kinds of information here. I urge you to go through and have a look at all the different areas in this website. I'll go directly to the wiki, which is the community maintained information site. There's a whole host of information here. We'll go directly to install, and we'll take the long-term support version Kinetic and install that on our Ubuntu. Our Ubuntu is the 16.04, which is also a long-term support. We'll do this just to have some continuity. You can of course install the latest one if you want to. So this is basically a copy-paste job. So we'll paste in this these commands into our command line. First, we'll set up the sources of the packages. So the packages we just installed was from Ubuntu, but now we need to get packages from ros.org directly. So we'll add that to our system, and then we'll set up the key so that we can actually log into the ros.org server. Then it says here to update, just as we did before. Now we just told the system that it can find packages in another place, but we didn't command the system to actually look which packages it is. So it's going through all that right now. Next, we need to choose which installation we want. We want the ROS Kinetic Desktop Full install. You can have the base or just the desktop, but the full install also contains simulators and everything that we want. So I'll just write sudo apt install ros-kinetic-desktop-full. Enter, and it will list all the packages that we need. So this package depends on a lot of packages, which in turn depends on a lot of other packages, and these are all the new packages that will be installed because of this. So alright, I'll just check here. You can see 2.3 gigabytes worth of packages will be installed. I'll just fast forward through this tedious download and installation phase. There we are. Now I'm going to install a tool that I think is very useful, which is called Synaptic, and that is a graphical tool for managing your packages instead of using apt. Apt is very nice for copy pasting from websites, and if you just need to do a small install of something. But if you want to explore what you have of options, I suggest the Synaptic manager. Of course, it's a matter of taste, but I'll just fire up the Synaptic so you can have a look at it. There we are. I'll click it. So of course it needs administrative rights, and for the first run it has this splash. So the layout is such that you can choose different ways of looking at the packages. You can look at the packages that you have installed. There's a whole lot of installed packages. As you can see, thousands. These are the ROS packages that we have installed, just installed, and you can see the green mark on the left-hand side indicates that it's installed. I just chose the desktop full. See, it depends on these 4 packages, but each of those packages depend on other packages. So you can also see which packages depend on what you have. So the desktop full depends on the desktop, and the desktop package depends on these packages in turn, and as you can see, it's a whole tree, and in the end we will install all these packages. You can also see a small note of what is inside each of these packages. Of course you can search through it, just if you want something. You can see here, be careful, you can both install something that's called ROS Desktop and ROS Kinetic Desktop. The ROS Desktop straight out is what's included with Ubuntu, because they're trying to merge ROS into Ubuntu. I suggest that you get the ones that are pre-pended with the version Kinetic, because those are more up to date. They're managed by the open source Robotics Foundation. You can also go to the origins and say I want everything that's from ROS, and here you can you'll only get the versions, so there's no ROS desktop, as you can see here. There's a lot of Python tools, and one of the things that we want is the Python Catkin tools, which is a nice set of tools for managing your software development in ROS. So I'll just mark it as install and mark apply, and it'll basically do the same as we saw in the terminal. It will download the software, it'll install the software without you having to type a lot of stuff. So depending on your preferences, you can choose either the GUI way or the command line way. Perfect. So next up we have Gazebo installed, which is the simulator. This is version 7.00, and because we're in a VirtualBox, there's some problems with the 7.00 version. So let's go to Gazebo Sim. The funny thing is, Gazebo is actually included in the ROS packages, but Gazebo is another project under the Open Source Robotics Foundation. So they actually have their own repositories. So we'll just get the newest version of Gazebo. Actually, the newest version is version 8.0, but we want the updated version of 7.0. So we'll, just as with ROS, we'll copy these installation steps. So we'll tell our package manager that it can find packages on the OSRF Foundation's website under Gazebo, and we'll get the keys to access that server. So it says apt-get update like always, but then the next step is to install Gazebo 8. We don't really want to install Gazebo 8. We just want to go with 7. We just want the updated version. So now if we go to Synaptic again, let's try out that tool. Oh, what happened? Oh, it's right there. Okay. We'll reload. That's the same as writing apt get update. So it's reading the package list and updating the database. So now if we go to installed and go to Gazebo, there you see it is outdated. There's a small exclamation mark. So we can update it, mark for upgrade. There we are. Let's do that. So it'll also install Bullet, which is a physics engine. We'll also mark all the other upgrades that might have occurred since the last time we upgraded. So there's something there. Perfect. And we'll apply this, and you can just check if what's going to be installed, what's going to be upgraded, and you'll click apply and it'll start downloading everything. And if you want to see what's going on there, I'll just fast forward through this download process. You can drop down this menu, and also if you're interested, you can check the details. That's the same output as you would get from the terminal. So really using synaptic, nothing is really hidden from you, which is the case with other software GUI managers. Alright, so now we've got our gazebo updated to the newest version. But with all my haste to get this gazebo installed, I've completely forgot to complete the installation steps for ROS. So let's just go back to the installation on Ubuntu. So we basically just downloaded everything, but it says to further initialize ROS step. ROS step is our or is a tool to check if all the dependencies of the software, the ROS software that you install, is available on your system. And the package management system, of course, does this for packages that's installed system packages, but you need, when you're developing something, you also need some dependencies, and the package management doesn't take care of that. So ROS-step will do that for you, or you will use ROS-step to do that. So first we'll initialize ROS-step, and then we'll update it so that it knows where to find all the different kinds of software that it needs. Next step is to set up our environment. Basically we'll copy paste this line here, which tells the system to run this setup bash script every time that our terminal is open. So every time a terminal is opened, it'll run this bash rc script, and as you can see in the bottom, with this command just appended source up /ROS/kinetic/setup bash. So it'll basically set up the path so that the system knows where to get all the ROS executables. Let's try out and see if ROS core works. It doesn't, and that's because bashrc has not been run from this terminal. If we open up another terminal, the bashrc will have been run, and the ROS core works. Perfect. So we actually have a working ROS installation. You don't need to know about ROS core just yet, but it works perfectly. There's a couple of other dependencies for when you're building packages, and we'll definitely be building and developing packages, so let's just install these extra stuff. Next up is to install our Turbot software. So the Turbot is a robot that we'll be using in the ROS courses here at Aalborg University to teach you how to work with ROS, but also how to work with robots, actual hardware robots. So you'll get a robot each, but there's several robots that are available that works with ROS, and there's this big page that shows a lot of these. It is so big that I can't even find the Turbot that I'm looking for, so I'm actually going to search for it. Turbot 2. There we are. The Turbot 2. This takes me directly to the Turbot page about the Turbot, and I can see what's up with that. And basically what I want to do is actually go directly to the wiki side of the Turbot. So here, just like for the installation of Ubuntu, there's a guide for installing all the software for the Turbot. There's a lot of other stuff that I urge you to read because it's quite invaluable. However, the installation instructions are a bit old. They're for the Indigo distribution of ROS. Indigo is I in the alphabetic sequence, so kinetic is K. So it's a bit old, but it's almost the same. We just need to be a bit intelligent when installing all these packages. So it tells us to install all these different packages: the Indigo Turbot, Indigo Turbot apps, Indigo Turbot interactions, and so on. And I choose to do it through Synaptic because I feel like I have a bit more control over the installation process through Synaptic. So we'll go to the origin. We definitely need packages that comes from ROS. So there we are. And I'll search for, I'll go directly down to ROS kinetic dash Turbot. There we are. And all the Turbot software is right here, right? So we need to install the ROS kinetic Turbot, of course. And it prompts us to install some of those dependencies. Then the other one was the Turbot apps. So the Turbot apps are some applications that you need or that you can use to interact with the Turbot. It also prompts for some extras to install. Then we want to install the Turbot interactions, which is apps to check for battery state and general debugging of the Turbot. Then we want to install the Turbot simulator, which in turn will install everything that's needed for the simulator. So remember, Gazebo was our simulator, so it's using that, so it's all the extra files for that. So now we basically have everything that we need. So that's the Turbot create package. We don't need that because that's the old, the Turbot 1 Turbot actually. Okay, so it will start downloading. We will just fast forward through that. Suddenly something happens, and that is because there's a problem with one of the drivers from one of the depth cameras. We're really not going to use that depth camera right now, but you'll see that it turns out there's a system problem, and just to investigate, I'm going to see that it's actually the library for the RealSense camera. We don't really care about that, and that's not reported because, well, I think you should report it if this happens on your machine, but because this is an instructional video, we'll just skip that. Okay, so we've got all our Turbot software installed. Let's just close everything down, and whenever this happens with the resizing of the window, I just like to restart. And we're fast forwarding through the boot process. Now we're back, and next thing we want to do is to test that our simulation is working. First I'll start ROS core, which is the core server of our ROS system, keeps track of everything that's related to ROS. Next I'll ROS launch a launch script from the Turtlebot Gazebo package. Remember, Gazebo is our simulator, and inside of that package there's a script. I'll just double tap on my keyboard to find out I want the Turtlebot world.launch, and this will start up everything that is needed to run our simulation. Gazebo will start up, and it will fail. This is because of us running in a virtual machine. Had you been installing this on your laptop or desktop natively, it should probably work. Anyway, we're waiting patiently, and there it failed. So doing some Google investigation on this problem, I figured out that there's actually it's related to the GPU and in the virtual machine. So the implementation of OpenGL 3 is not complete in VM. So what we need to do, we'll just leave the stuff closed. We'll need to set this environment variable svga underscore v GPU, CPU GPU 10 to 0. There we are. That will default our use of OpenGL to OpenGL 2.1, and now everything should be working. There we are. Gazebo is launching, and what will happen is that we will see a world of some obstacles with a Turbot inside of it, as you can see here. And I can use my mouse to navigate this 3D world. I can left click and I can zoom. I can right click and I can zoom, and I can left click and I can move the camera around. And I can change the orientation by middle clicking. I could also shift click. So down here is the real-time factor. As you can see, this simulation is almost running at the same time, at the same speed of real time. I'll open up a new terminal, even another terminal, and I'll ROS launch the Turbot teleop. So teleop is short for teleoperation, remotely operating the Turbot, and double tapping on the tab key will show me which launch scripts I have available. There's the keyboard launch script, and now it says here that I can move my Turbot around with my keys. So going into Gazebo, nothing works, so I need this terminal window to be open in order for the window to catch my inputs. So if I press L and J and O and so on, the Turbot will move around. So I can move the Turbot around using this, just like a remote controlled car. And if I feel like I can't see anything, I can just move the window out of the way. It's still active, so it's the one that's really getting my keyboard strokes. And as you can see, it's a physics simulation, so when the Turbot hits something, it will stop. We can move the box ever so slightly because it's very very light. If I think everything is going too slowly, I can increase the speed. If I want to quit, I'll press Control C. So Control C is the default for terminating a process inside of a terminal window. I'll do the same here, so I just terminated the Gazebo, but some of the nodes are still running. I'll terminate the ROS core by clicking or typing Control C. Perfect. Everything is shut down. So we've got ROS running and we've got our simulator running. Now it's time, I think, to just nicify our system a little. So the first thing I'll install is Terminator. You saw I had all these terminals open at the same time. Terminator is a terminal emulator that will that is quite useful when you have several terminals open. So just sudo apt install Terminator, and it's a small program. It will download quickly. If I press Ctrl Alt T now, you'll see that my new terminal is the Terminator. To begin with, it doesn't really look like anything particular nice, but the nice thing is that you can split these windows however you like. So now I have the three windows that I had before, the ROS core running. In the next one I'll launch the Turbot simulator, Turbot Gazebo, Turbot World, launch, yeah. And in the last one we'll launch our Turbot teleop node. but suddenly our simulator stops working. Of course, it's the same problem as we had before. I just forgot to make a permanent solution for this problem. So we need to actually, just like we set our bash RC to source this setup.bash from ROS, we'll just go in and set it to export this environment variable that we had to set. So export svga underscore vgpu 10 equal to 0. There we are. Save, close, and we'll just resource the bash RC instead of reopening a terminal. ROS launch, just as we did before. And now everything's working just as before. Remember now that you have several windows inside of this window, so if you want to use your tail hub, you need to activate that specific window in order for that to capture the keystrokes that you're doing when you're doing tail operation. You can see the red heading on the active window. We'll also launch ROS, which is the robot visualizer in ROS. Notice that you don't need to type ROS launch or anything, just ROS. So this is the first time ROS is running, and it'll take a little time. I'm just playing around. Okay, so this is ROS, and what you see here is basically what the robot sees. So first of all, we'll say what is our fixed frame, what is the coordinate frame that we're working with here, and base footprint is the coordinate frame that's attached, well, to the footprint of our robot. We'll input a robot model, so we have the 3D model of our robot, and we'll just place that in the coordinate system that we have, so we have an idea of how big our robot is compared to the environment. Then we can add different visualizations. So first we can add the point cloud visualization of the depth camera of the robot. So as you can see here now, the robot has the depth camera, and what it sees right now is not that interesting, but it actually sees a wall, and that wall is actually the wall of the white cube that you see here. So let's try and move the robot around to see if we can pick up some more interesting features. There we are. So now the robot is has been moved over to have a look at the concrete wall there, and as you can see, we'll see a concrete wall inside of a robot visualizer. We won't see the entire world because we're only seeing what the sensors of the robot is actually sensing. And we can have a look around inside of ROS, and you'll see that this point cloud is only seeing one surface of the concrete wall. So we're not getting a full 3D representation, we're actually just getting a point cloud of it. Okay, so I'm closing without saving the settings of ROS. If you have a special setup that you want to save, of course you go ahead and save that, so you don't need to set it up every time. So this is the beauty of well, a lot of tools now. Terminator, I'm just going to terminate everything in our terminals. But Terminator also has a lot of possibilities for being made to look nice. So I hate this red border when something's active, so I usually set it to something green, which is much nicer, right? Also, you can set the colors of the text and of the background. I'll use the solarized template as basis, and then I'll just tweak it a little to my needs or wants. So if I try to write ls to see which files I have in my folder right now, it'll color code the folders to be blue and the files to be gray. Also, the background, I like to have it transparent. You can have it very transparent to see everything that's behind it. It looks very cool, but it's not as productive, I find. So I like to set the transparency to something a bit opaque. So it doesn't really look like it is transparent anymore. But if I have some text from, let's say, a website that I want to use, then as the terminal is floating, I can actually see it through the terminal, which is very nice, and I have a good idea of what's on my desktop. Anyway, that's just how I like it. Also, I want to tweak the colors a bit more. We can use the scheme of solarized dark for the background color and the general text color. So this is now everything looks a bit more geeky and flashy. I like that. So this is my default setup usually. So I'll just close down Terminator, and now I want to get rid of some of the extra stuff that's available on our system right now. So we're only going to use this for ROS. We don't need all the Office applications. They're called LibreOffice, and they're free, and they're available for Windows as well. So if you like them, please keep them around or install them. But I'm going to get rid of everything that takes up space here, because it's a virtual machine. I don't need several gigabytes of software lying around. Really, I'm searching for the preferences here, and I forgot where it is. There they are. Okay, so I just want to add the column that says what's the size of the installation. As you can see here, I can sort for the biggest sized objects. I'm going to uninstall what I don't need. So this seems strange to remove the Linux image, but that's the old image of 4.8. I'm going to remove this no tofu font. Also, there's Firefox, but sometimes I use that even in a VirtualBox. You can get rid of it if you want to save those megabytes. There's the LibreOffice core. If I remove that, it'll remove a lot of the other LibreOffice stuff. You can see now we're essentially removing 1/2 of a gigabyte. Thunderbird, that's the email client. We'll get rid of that. We don't need Thunderbird either. Going down, there's the Gazebo 7. Of course, we need that. LibBoost. The boost is there's a lot of C++ libraries. We need those. Oh, some more LibreOffice. Remove that. Then we have some Linux headers. We're running 4.10 now, so we need those. But 4.8, we can really remove those without any problems. There's also the Linux headers of 4.4, but I think that's I noticed that they were installed with some of the ROS packages. So if we try to uninstall those, we'll also uninstall the ROS. So we'll keep those around. We have the Ubuntu docs, so that's really documents. I don't need those. The snap daemon is for the Ubuntu core. It's a new way of distributing applications for Ubuntu. We will not need those either. We can remove some of the GNOME user guide here. Really now we're getting down to the smaller stuff, but we've actually gone and removed about 1 gigabyte of programs right now, just with this small operation. So let's go ahead and apply all this. So you can see I completely removed a lot of stuff, but a lot of it, the dependencies are only going to be removed. So all the configuration files and so on, they're not going to be removed. So under status, there's a pane that's called installed but auto removable. I'm just going to mark all of it and say completely remove all of it. So when anything is auto removable, it's because it's not being used by the system anymore. Next up, I want to remove the last couple of icons here from the bar. I don't really need those, apart from the Firefox. That's very handy. Next, I want to get another text editor. And my favorite right now is called Atom. That's being developed by the guys at GitHub. Actually, you have text editors on your system already. We actually just used one that was called gedit to edit our .bash RC file. Gedit is quite useful and it does help us in a lot of ways. So if we're going to develop C++, it will color our code. So if I just write a standard main function here, you will see that the types int and char is being colored, and I can write a standard hello world program, and everything will look very nice. The problem with gedit is actually the time it takes to develop such a simple program here. Now I actually sped it up, so it took the best of 1.5 minutes. So this is the way that I would create a hello world program. So I'll just put it in a folder on my desktop, new folder named hello, and hello cpp, save. There we are. So now we just developed a hello world program in gedit. There's also VI or VIM. I haven't installed that, but VI is the base version. It will run inside of our editor, or sorry, the terminal. Also there's Nano that people like to use, also running inside of the terminal, and that actually does color code. To exit, we will press Ctrl X. There we are. Okay, so, but I like Atom, and it's not a part of the package management system, so we'll download this .deb file. Deb is short for Debian, which is what Ubuntu is based on, so we downloaded that. And to install a Debian that is not a part of the apt system, we need to use the dpackage tool -I for installation. On the downloads, Atom, so it says, oh, you need super user privileges, so I'll say sudo double exclamation mark, and then often I forget to use sudo, and the double exclamation mark is really just copying whatever was in the last line, so it's basically just writing sudo dpackage -I downloads Atom yada yada. So now it's unpacking and installing. Alright, we're done, and now we can run it by typing Atom, and the program will open up. Atom is based on web technologies, so you can basically hack anything behind it with JavaScript. So there's some welcome messages. You can have a look at those if you want to. Telemetry content, this being a virtual machine, I'm not going to send it. You can turn it on if you want to. So Atom is a bit more powerful than the rest of the bunch I've shown you. And so now I'm opening up the Hello World program, and as you can see, it's color coding, and it already did figure out that it was C++ code and that we were dealing with here. Let's try and develop another Hello World application in Atom, and you'll see how such a program can be written quite fast. So I'll just write main tab because it helps me already, and then in the code I want to send something to cout, yes, and I'll tab to use whatever it asks me, and this is not sped up at all. So as you can see, this is much faster. But let's try and introduce an error in this program, and we'll see how we can cope with that. So we'll just forget this semicolon at the end, and I'll go to my terminal and I'll cd into the folder hello, and in that folder I'll compile gcc hello.cpp. Yes. Oops. Okay, there's a problem here. So probably I wrote something wrong. That's also the problem of writing things out. So that's what I did in gedit. Actually, when the program helps me write stuff, it's a bit easier. So let's try and compile hello to CPP. We know this is wrong, but we get something useful, right? So it says here that cout is not a member of std. Oh, that's right. That's because I forgot to include the IO stream. So inc, oh, there it is. I just need to write inc and tab. There we get it. And I can just write IO stream. So IO stream, that is the library that has the cout part of standard. Now it says, error. I expected an semicolon before return. Okay, so I need to go and put that in. But this is a quite tedious task of alt tabbing between these two windows. So I'd much rather have that everything was running inside of Atom. And I can really configure Atom to my needs by actually installing packages that will extend Atom. So first, let's install a linter. So linters are programs that checks your code as you're writing it. This is a base linter, so that it basically doesn't know how to lint any languages. It just has all the features of a linter, and it has cow powers, which probably is great. Now we're using GCC to compile, so there's a linter that's called linter GCC, but I figured out that it's so okay. So do you want to install the dependencies of linter? Yes, I want to do that. So there's another linter that's called linter clang or clang, which uses another compiler, but it has some benefits over GCC. So we'll install that. So one of the benefits is that there's also an autocomplete package using clang. So autocomplete, you can see there's autocomplete modules for Java, for Haskell, JSON, a lot of different languages, but we specifically want the one that's using clang. And we'll search for it and install it. There we are. If we have a look now into our file, clang should come up with the linter and say something's wrong. Error running clang, of course. We need to install clang because GCC is actually the only compiler we have right now. So we'll go into synaptic and we'll search for clang. Mind you, we could also do this from the terminal. So there's a lot of different clang versions here. We'll just go with clang without inversion because usually that will depend on the latest version. Actually, it depends on the not so latest version, 3.8, which seems okay. We're only going to use it for linting. So that's that installed. And let's close down Synaptic. Go back into Atom. So let's just save hello world with the problem. And there it is. We have a small error, and it comes up here. It says clang says expected semicolon after expression. Very nice. And let's just input that expression. Oh, sorry, that semicolon. Also, if we remove this include IO stream, it would come up, say, the use of undeclared identifier standard. Yeah, so very nice. Let's put that back in. There we are. Next, I will show you how the autocomplete feature works. So just writing standard : all the possible completions to that expression is available through the autocomplete feature. And that's very useful when you are working with a class or with some code that you have an idea of how it works, but you just want to tap yourself through it. Okay, I have a couple of other packages that I think we should install. One is called file icons. If you have a look at the icons on the left hand side, they're just marked by if it's a file, if it's a folder. Sometimes it's nice to know if it's a C++ file or whether it's a text file or something else. And while that is installing, I want to install a package that's called Minimap. Minimap, people might know if you have been using some Sublime text. It will make a preview of the source code on the right hand side. Now you can see that the file icons was installed, so there's a small C++ icon next to our folder. I'll try and make a hello world .h file, which is a C file, so it's a plain C file. If I change that to something else, PHP maybe, there's a small elephant which signifies that it's a PHP file. Let's try another one, py for Python. There you are, it's a snake. So it knows most of all the file types that you might work with. All right, delete that. Okay. So going into the Minimap, we've got that installed. And you can see that actually on the right hand side here, that you have a small representation of all the text that's in the file. And that's very nice if you have a long document and you know the structure of it. Next up, I want to show you a feature, the ToDo feature. So if you're working on a project and right now you don't really know how you want to implement something, or you don't have the time, you can write in a comment. -- means that it's a comment, it's not an executable piece of code. So you write ToDo. If you want to find all the to-dos in your code, you can of course Control F to find, but there's a package for that as well, which will list all the to-dos that you have in your document. So I'll just search for ToDo, and there's actually two, one ToDo and ToDo show. I'll use ToDo show by, I think he's called Michael Rødelsgaard or something like that. He's from Aarhus. You can also see it's been downloaded 200,000 times, where the other one's been downloaded 10,000. So as with all the other packages that was installed, actually there's a setting. So if you click that, there's a lot of settings that you can tweak your packages with. And there's also a README file where the authors show how to use your package. And this one says specifically to use Alt-Shift-T to toggle the to-do list. So Alt-Shift-T, there we are. And it says here, yes, there's a to-do, write out some more text, which is a nice way to show all the to-do, so you can kind of have an overview of what's to be done. Okay, let's get rid of that and write some more text out. Hello world, accompanied by goodbye, cruel world. Yes. Now that I have two almost identical pieces of code, maybe I want to be able to highlight all of that looks alike, but I can't do that by just double clicking on it. There's a package for that as well. It's called highlight selected. It might seem strange that all of this is not included in Atom from the start, but it's actually made so that you can customize your editor to suit your very needs. And I think that's nice because people from all over the place is using Atom, both for web development and for hardcore embedded development and so on. So it's nice to be able to tweak your editor as you want. Now I've got highlighter selected, so if I double click C out, you'll see that it also highlights the other C out, but also in the minimap. If I double click world, the other world will not be highlighted because it's of a different character, or sorry, case. Next, let's install something for ROS. So remember we had the Catkin tools installed that was being used that is going to be used to build our ROS software. So there's a package for that as well. It's called build Catkin tools. We'll install that. It's only been downloaded a couple of hundred times, but then again, this is a niche product. Build Catkin tools is depending on build, and which is another package. Atom build, it says here. So we need to install that as well. For some reason it doesn't do it by itself. Also, it needs to know which ROS version we're using, so we'll write kinetic. There we are. Back into install, build, install that. And while we are installing the build, we can go and fetch some code that we can actually build. I'll just go and get the Turbot ToDo up that we were using. So onto the ROS wiki, it shows everything about that, and we have a link to GitHub, which hosts most of ROS code. So this is the location of it, and we'll copy that. We will not get the zip file, but rather we will use a download method that's called git, which is very useful for keeping track of your software. So let's just make a folder for our downloaded software. We call it Catkin workspace. And inside of that folder, we'll make another folder called src for our source. We'll just also run catkit init to tell that this folder is a Catkin workspace. Okay, so cd our source folder and git clone. So we'll clone whatever software is available on that repository. So let's go back into Atom and close our hello world program down. So, that might be a stupid way to do that. Anyway, I'm going to add a folder that we have there, the Catkin workspace. So the Catkin build package expects the base folder there to be our workspace. Then we can look at the source and go into Turbot ToDo up, look at that source. That's the CPP file for that. Let's close down these CPP files. There we are. And well, actually, in the README file for the package for Catkin build, it says we need to build the Catkin workspace once before it works. So we'll just go to the terminal and write catkin build, catkin space build actually, and it will start building. And you can see each of the packages inside of the package that we downloaded are being built. Or sorry, each of the applications inside of the package is being built. So now if we go back to Atom, we can have a look at this is the Turbot joy cpp file, which is the program that takes care of teleoperating the Turtlebot through the input from a joystick. So let's see if we can find a suitable place to input some code so that we can actually build it again. Remember, it was built already in the terminal, so I'll just put in another integer here that's called not used, and save the file. Control S for saving. Now in order to build using this catkin build, we can go to our package in order to see how it works. So we'll have a peek at the readme file. So go to settings, and if we scroll down, we'll get past the settings and we'll get into the key bindings here. It says F9 to build, and if we scroll further down, there's some, there it is, and if we scroll further down, you can see you can also Control Alt B for building. So if we do that, Control Alt B, it will start building, and you'll see the output just as we did in the terminal before, just without all the pretty colors. Okay, and we get the pop-up saying that everything succeeded. Very nice. We still have a problem here that Clang says it cannot find ROS.h, but GCC or Catkin that we used actually did compile. How on earth does that work? Well, that is actually because if we go into our Clang Linzer, if we can find it, there it is, and down in the setting, in the README, it says project specific settings. So if you add this .clangcomplete file to your project, you can tell it which folders to look in for include files. So .clangcomplete, there it is, and then we need to input the compiler options to find our include files, and I happen to know that they're located in /opt, /ros, /kinetic, and there you can see that we have the include folder in there. So, and in that include folder, if we scroll up a bit, we'll see there's the ROS folder, and in the ROS folder there is the ROS.h file. So what we basically need to do is that we need to tell Clang that we need to have include those. So you write $I for include, and then you just write the exact path to your include folder that you want to include. You can have several, you need to put them on a separate line. So there we are. And if we go back into our C++ file, we'll see that it's marked with red still. Something must be wrong. Oh yes, of course, we need to restart Atom because it reads this .clangcomplete on boot time, or when the application starts. So it knows where to complete. So there we are. No red anymore. Very nice. And that also means that it is able to autocomplete things from that specific folder. So here we have a warning that says this field is not used. Of course it's not used. That's because that was the integer we added that wasn't used. So we'll just remove that. Okay. So basically that is everything. Now we have a working installation of Ubuntu, we have a working installation of ROS, and we have a working installation of Atom with some packages. Thank you very much. And let's just close down our machine. Bye.